Okay, this is for 4-6 during your SIR on 23rd March. So the questions given here is that the class is not sure about how to interpret two things. One is your displacement time graph, right? You're not too sure about how to interpret displacement time graph, as well as velocity time graph. Okay, so this video will be uploaded onto your Google Classroom, alright, so that if you need to revise, you can refer to it anytime. Okay, so let's talk about your displacement time graph. How do you actually interpret a displacement time graph? So basically, there are different kind of shapes, but for whatever kind of shape that you have in your displacement time graph, always remember, whenever you're looking at graphs, the few important things you have to remember or check is actually one, your axis. What does the axis represent? Okay, the x-axis and the y-axis. That's the first thing. The other thing you need to look at is actually the coordinates. And then of course, the last one would be your gradient. Okay, so these are the three things that you actually should look at. So let's look at the very direct one. Okay, when you have a horizontal graph. Okay, so when you look at a horizontal graph, as mentioned, right, you need to look at the axis, the value of the axis over here. So if let's say for a displacement time graph and it says 5, okay, and the time over here is 1, 2, 3, and 4. Okay, so you notice that what happens is that even though as time progresses, the displacement remains the same. Right? And that's actually determined by, as in you can see it through your gradient. So notice that the gradient over here is actually equals to 0. Right? Your gradient equals to 0. And the gradient is actually y-axis over x-axis. So the units will eventually will give you a value of 0 meter per second, which means that the speed of the object is actually equals to 0 meter per second. So this is how you interpret. First thing you always look at is the axis. Okay, the second thing look at is actually the coordinate values. Okay, and then the last thing that you must look at is definitely the gradient. Alright, each one of these will tell you some form of a story or some form of a meaning behind it. So if I have another graph, again it's a displacement time graph. Okay, and right now it's actually a straight line diagonally as such. Say for example, this is for 5 seconds, and this is actually 5 meters. Okay, so by looking at the axis, you know that this is talking about displacement time graph. So if I would like to find the displacement, I can actually just look at the y value, okay, the y coordinate over here and over here. This is actually your final displacement and the final time, right? So I can actually look at, say, at a lower value over here. For example, if this is 1 and this is 1, I will know that if the initial velocity is 1, okay, and the final velocity is 5, and the time difference is actually 5 minus 1, I can actually find what is the gradient, right? So by looking at the gradient of the graph, I can actually find what's the velocity. Okay? Oh, so sorry. In front, I shouldn't say speed. It should be velocity. Okay, so remember, your gradient in this case tells you your velocity, which for this case is actually 1 meter per second. Okay, so next we can move on to look at your velocity time graph. So velocity time graph, there are actually more things that we can look at. So again, I'm just going to do 2 simple exercises, but to highlight the most important things that you need to look out for. So, for example, you have this. Okay, again, it's a horizontal graph where you have your time axis going in such a manner. Okay, 1, 2, 3, and then 4. Right? So, similar to what you have seen earlier on for displacement time, you need to first take note what are the axes. Okay, axis is actually velocity and time. So the y-axis, like the value over here, 5, actually tells you the velocity. Okay, and the time over here, the x-axis, the values over here actually tells you what's the time, okay? And at that point in time, what's the velocity of the object? Alright, so next thing you also need to take note is to look at the gradient. Okay, we look at the gradient over here. So for the gradient over here, you notice that the gradient is actually 0. Okay, and gradient in this case, right, is y-axis over x-axis, which means velocity over time. So change in velocity over change in time actually gives you the quantity of acceleration. Okay, so in this case, that tells you that acceleration is 0 meter per second square. Okay, 0 meter per second square. Which means object is actually moving at constant velocity, right? Since acceleration is 0. Okay, so if you compare, right, between your velocity time graph and your displacement time graph, it's the same shape. The values are the same as well, but it represents different things, right? In velocity time graph, given such a graph, you know that object is moving at constant velocity, right? Every second is moving at 5 meters per second. Whereas if you're looking at the displacement time graph that has the same shape, velocity is actually 0 meters per second. Object is not moving. So the displacement is 5 from t equals to 1 all the way to t equals to 4. Okay, so this is the understanding you must have. And of course, if you want to know how far has object traveled, you can actually find the area under the graph, right? Area under the graph. So learning points over here, whenever you're looking at the velocity time graph, a few things you need to put your attention to. The first one is of course the axis. The both axes, what do they represent? What are the coordinates? The coordinates, from the coordinates, right, the y-axis and the x-axis coordinate, you can actually find things like initial velocity, final velocity, initial time, final time, and therefore the change in velocity, the change in time. Okay, and that is actually part of your gradient. Okay, and of course the last one that you have over here is the area. Of course you will notice displacement time graph, there's only gradient, up to gradient, but velocity time graph, there's an additional area. So what does the area represent? The area will represent the displacement. Okay, and the gradient over here actually tells you the acceleration. So whenever you are looking at a velocity time graph, you can actually find out what's the displacement of the object. You can actually find out what's the acceleration of the object. Okay, what's the initial velocity, final velocity. Alright, by looking at the coordinates, you can actually find initial velocity, final velocity, t1, t2. Okay, with this so far. So right now, let me just show you another example of a graph and let's try to understand what it means. Alright, so this is a velocity, meter per second, t per second, and we're going to draw this. So this is 5, this is 5, this is 1, and this is 1. Okay, so by looking at the y coordinate, I know that this is 5. That means the velocity at this point is actually 5. Okay, and the time taken at this point is actually 5 seconds as well. Right? Then let's look at what's the initial velocity. The initial velocity over here is actually 0. Right? Initial is actually equals to 0. And the 5 over here is actually your final velocity. So the time, right, is also 0 over here. And when your final velocity is 5 meters per second, the time is actually 5 seconds as well. Alright, so by looking at this, you can actually find the gradient of this graph, and the gradient of the graph will be your 5 minus 0 divided by 5 minus 0, where the top is actually change in velocity over change in time, and you get 1 meter per second square. So that tells you the acceleration. Okay, this tells you the acceleration of the object. And then of course, we can talk about the area under graph. So as we mentioned earlier on, right, the area under graph is actually the displacement. Why is it that this actually gives us the displacement? Because if we look at the axis, V and t. By multiplying these two, we actually can find displacement. Right? Displacement is your velocity times time. Okay? Yeah, so in this case, right, half times the base times the height will actually give you the area. And in this case, it's actually half times 5 times 5. That gives you 12.5 meters. Right? So 12.5 meters is actually the displacement. So in this case, this is how you look at what is happening. For now, what I've actually shown are all the straight line graphs. So if you actually have a curve, you still can analyze it the same way as I've done initially. Okay, now just take note that because the gradient is changing in the velocity time graph, it tells you that the acceleration is changing. Right? For displacement time graph, it is a curve. The gradient is changing. It means that the velocity is changing. Okay, that's all for this part.